All right, are you guys so excited that we get to do a word problem with inverse variation? So if you remember, our first step to every word problem is to read the word problem. So the inverse variation, x times y equals 2400, relates to the vibration frequency y in hertz, Hz, to the length x in centimeters of a guitar string. Determine a reasonable domain and range. Remember, domain is your x's, range is your y's. And then graph this inverse variation. Use the graph to estimate the frequency vibration when the string length is 100 centimeters. So our first step, it's kind of nice. It's walking us through it. Solve the function for y so that we can graph it. So if we take our function, xy equals 2400. If we solve this for y, so we divide by x, we get y equals 2400 divided by x. Here's our inverse variation function. Our constant of variation is the k value, which is 2400. All right, decide on a reasonable domain and range. This is just going to help us when we create our table of values, and to just make sure that we're working with values that make sense in the context of this word problem. So our domain is all of our x's. X is representing the length in centimeters of a guitar string. So if you're measuring in centimeters, you're going to have either 0 if it has 0 length, or all positive numbers. Nothing will be negative when x is the length in centimeters. But also x is in the bottom of our fraction, so x cannot be 0 because 2400 does not divide by 0. So basically a reasonable domain is all of our x's have to be greater than 0. Okay, now our y, which is our range, what's a reasonable range for this situation? So on this one, I'm just going to refer back to, we know that x times y equals 2400, and x is a positive value, and we're getting a positive result with this multiplication right here. So a positive times what type of number will give you a positive answer, another positive value. So for our range, all the y's will be greater than 0 as well. Okay, so use the values of the domain to generate reasonable ordered pairs. So again, y equals 2400 divided by x. We know in this case that the reason why we talked about the domain is we're not going to pick any negative numbers, and we're not going to pick 0 because that doesn't make sense in the context of this problem. Even though 2400 will divide by negative values, we're not going to put those in our table of values. So this graph will be one of the curves, one of the parts of the two-part inverse variation graphs that we've seen so far. So what does, and I'm going to pick, if you kind of glance below, you can see we've got a table of value, or a graph with some bigger numbers. So just think, what will 2400 divide by? Let's go big. I'm going to let x equal, as long as they're positive numbers, we're good. It'll divide by 20. It will divide by 40. 60, and I'm just gonna jump one higher, 120. So I was counting by 20s, and then I just wanted one more number a little bit further up. So let's plug those in. 2400 divided by 20 is 120. 2400 divided by 40 is 60. 2400 divided by 60 is 40. 2400 divided by 120 is 20. So, plot the points, connect them with a smooth curve. So I'm going to get this graph. Here we go. Okay. So if x is 20, y is 120, that is way up. Oops, that's not my... There we go. There we go, 120. All right, if x is 40, y is 60, which is right here. So all I'm doing is I am plotting these ordered pairs. Okay? So if x is 60, y is 40. Oops, that was not in the right spot. Let's try that again. There we go. And if x is 120, so I went all the way to the edge to see where this was heading toward, y is 20. So connect them with a smooth curve. So we've got our inverse variation from our word problem graphed. Now we can answer this question. Use the graph to estimate the frequency. So it will be an estimate based off of our own graph. The frequency of vibration when the string length is 100 centimeters. So let's remember our string length is our x's down here. So if that is 100, so I'm going to go along the x-axis to 100, and then I'm going to go up and estimate where this is. Honestly, it should have been just a little bit up. If you noticed when I graphed, I kind of missed this point right here. So really my curve should have been just a little bit higher. So I'm just going to keep that in mind and go a little bit above, and I'm going to estimate. If I head over to the left, that's at 20. I can see these are counting by fives, right? 25, 30, 35, 40. So it's just a little bit more than 20. Maybe I'll estimate that it is 22. That the frequency of vibration is 22. Well, that looks like an HX on the axis, but I thought it was HZ on the word problem. Let's see. Yeah, HZ. Well, okay. I guess I'm not sure what the label should be. I'll put or HZ. So we plotted it, we drew our graph, and now we can answer any follow-up questions like we just did in step 5.